Okay, so once again, to turn this diagnostics on, you hit second catalog, second 0, then scroll down to the word that says diagnostics on, hit enter. Then it's going to say, do you want me to turn the diagnostics on, hit enter. When it says done or whatever, you're good. So everybody with me? Okay. All right, now we're going to get started. So everybody, what we're going to be doing today is modeling polynomials in the real world in a sense. Like I said, we're just going to be using our calculators to do all of this, so it's going to be pretty simple. You do have to understand a few basic things, like just you have to know a few things. So everybody, we know that this unit we've been focusing on polynomials of any degree, correct? We've really gotten on solving polynomials of any degree. So today we're just going to be given a set of xy points, such as these, and we're going to determine if it's linear, quadratic, cubic, quartic, and so on, which we already know how to do that one way, right? Looking at the differences of our y values, right, everybody? But there's an easy way that's even easier than that. So everybody, I just want to show you something. If I plotted these xy points, I'm telling you I've already plotted these points right here. Do you see how if I draw a line, it does not connect the points? So we know it's not linear. With those same points drawn, do you see how I draw a quadratic? Do you see how it's a better fit than a line? It's a lot closer to connecting than a line, but it's still not a perfect fit. Everybody good with that? And then notice, I then draw a cubic, and it connects the points perfectly. Does everybody understand? All right, awesome. So what you're going to do, let's say I said to you, okay, given these points, what is the polynomial? That would be really hard to find without, if I didn't just say what's the degree, if I said the degree is 3. We know the degree is 3, but what is the polynomial that gives you those xy points? You could use your calculator to find that. So everybody pull up your calculator. Now you're going to have this memorized. On the test day, you come and say, wait, how do you do that again? During the test, I'll say you should know that, okay? So make sure you remember this and practice it. So you hit the stat key, stat. This is how you get there. Stat. Then we're going to go into edit. Now, a couple things to note. See how I have a list 1 and list 2? Does everybody have list 1 and list 2 at the top? If you're missing a list, it's because you've accidentally deleted it. So let me show you what not to do. Now, we can, so list 1 and list 2 is what we need. Notice if I go up here, if I hit clear, are we all paying attention? If I hit clear and scroll down, do you see how it clears out the list? Now, if I accidentally go up here and hit delete, boom, it will delete the list, and then I'm going to be in big trouble. I'll have to reset my calculator because then it won't calculate it correctly because you won't have list 1. You'll be typing it into list 2 and list 3. That list 1 would disappear if you deleted it, and then we don't have our settings set up so that we can do it in list 2 and 3. Okay, so everybody, if you go up here, you can hit clear, and it will clear out the list. Do not hit delete. If you do on accident, let's all learn how to reset our calculators, okay? Are we already going to learn it? Ready? You hit second memory, second plus sign, and we go down to reset. And then you go through the motions of resetting it. That would give you like a brand new calculator. So I'm not going to keep going because I don't need to reset mine. Anyway, so I hit the stat key. We're going into edit. And then in list 1, what you're going to do is type in your x values. In list 2, you type in the y values that match up with those x values. So I'm going to pull this back down and let you type those in. So everybody type in 0, 5, 10, 15, 20. That's what you're typing into list 1, x values. In list 2, you're typing in your y values. So in list 1, we have 0, 5, 10, 15, and 20, correct? Okay, in list 2, you've got to type in the correct y value with that x value. So it was 10, 10.1, 2.8. Now let me show you something. Let's say I hit enter and I typed it in wrong. I go up here. I don't want to have to go retype in the whole list. Now notice clear won't work. It doesn't really work. You'd have to hit delete. And then you can scroll, oh, right here, delete, and then it will be gone. Okay, anyways, 2.8, enter, 8.1, 17.8. Okay, does everybody have this typed in? Now here's a couple things. If you ever get the word error when we go to try to do the next step, it's because you have extra things typed into your list 1 or list 2. If you don't have those exact points and only those points, if you have extra stuff, it's going to calculate something either wrong or it's going to say error. So we got to make sure that these are right. Okay, now that we know that they're right, all you have to do is click the stat key again. So we're dealing with the stat key. Hit the stat key again. Now instead of being an edit, we already edited our list. We're going to go over to calculate. Now looking from, remember back to when I showed you the pictures, don't we know it's a cubic? Because that's what connected the dots, correct everybody? So we're going to go down to cubic regression line. Because that just means the polynomial is cubic. So cubic regression line. Is everybody there? Yeah. Hit enter, and then hit enter. And it might, some people's calculator might make you enter through a couple things before it gives you this. So notice it gives you the form of a cubic, ax cubed plus bx squared plus cx plus d. It gives you the a, b, and c values and d, the a, b, c, and d value. Yeah, it's awesome, right? And then this r squared, we need to understand what that is because we're going to use it. R squared isn't in the polynomial equation. What r squared is it's telling you how perfect of a fit it is. What percent perfect fit it is. Do you see how this is 0.999? That's a 99.9% perfect fit. Does that make sense? Like a cubic was a 99.9% perfect fit. So that's pretty much 100%. Does that make sense? So the closer r squared is to a 1, the closer it is to 100%. So if you ever get r squared 1, that's an absolute perfect fit. Does that make sense, everybody? Yes. Yours says 1. Yeah, so everybody's calculators will be slightly different. So 1, that means it was a perfect fit, which ours would round up if we did round. Does that make sense? Now let me just show you. Let's say you calculated a quadratic regression line instead of cubic. Let me show you what happens. So I'm going to go to quadratic regression line. You can just look. You don't have to do this. Notice it still gives me an equation. But do you see how r squared is 0.76? That's only a 76% perfect fit. That's not a good fit, guys. It's got to be like 98, 99% perfect. Does that make sense? Or 1. We want it to be 100% perfect, but that's not always going to happen. Because you didn't turn your diagnostics on, so have somebody maybe show you how to do that. Okay, so awesome. Okay, so now here's one rule you do have to know. Everybody listen to the rule. Or you can test this 2 different ways. So it's called the n plus 1 point principle. Basically, I'm just gonna tell it to you basic, not read it to you. If you have 5 points, then there is a degree 4 polynomial that matches the data. Do you see how that's 1 less than the number of points we had? So if I have 3 points, there's a degree 2 that matches those points perfectly. Does that make sense, everybody? So let's look at number 1 on the worksheet. It says, find a polynomial function whose graph passes through each set of points. So the first thing you'd say is, okay, these are my points. I have how many points? 2 points, right? 2 xy points. So that means that there is a line. What's 1 less than 2? 1, correct? 1 less than 2 is 1. So does everybody understand how there's a line that will fit those points perfectly? Yes? Okay, so now we're going to use we could literally do this by hand. We could do y equals mx plus b, plug it in, go through the math, or we could use our calculator to do it for us. So on an ACT, if it ever says to you, given these 2 points, what's the slope? Wouldn't you rather just use your calculator to find the equation than look at the slope? That would be the easiest, right? And quickest. So now you go to your calculator and list 1. So we're going to stat, right? Edit. I'm going to go up here and clear out my list, not delete. That would be bad. Clear, and I'm going to go up here and clear. And then you have to scroll down for it to actually clear. Okay, in list 1, we had the points 4, and what was the other x point? -3. You guys have this on your paper. We're doing a problem off the worksheet. Okay, -1 and 13. Okay, now we're going to go stat, over to calculate. Now we decided this is a line, so we're going to hit linear regression line. I hit enter and hit enter. Notice, y equals mx plus b, correct? Ax plus b. It gives you a, so you typed in something wrong. So a is -2 and b is 7. Does everybody see it? Now notice, isn't r squared 1? So it's a perfect fit. This is the perfect fit. A line is a perfect fit. So we have y is equal to negative 2x plus 7, correct? Did you all get that? Why didn't you? I'm confused at why no one's getting it. Okay. Let's do number 8. Okay, so let's read it. Everybody pay attention this time. It says, find a polynomial function whose graph passes through each set of points. So everybody, how many points do we, so we've got to determine what degree, correct? So there's 1, 2, 3, 4 points. 4 points, so there's a degree 3 that matches those points perfectly. So we're going to be doing cubic regression line, okay? So in list 1, type in, I'm not going to do it. I'm going to wait for you to do it. List 1, type in 0, 2, negative 1, and 3. In list 2, 9, 21, 0, and 36. Then stat, calculate, and then cubic regression line. And then I want to know what's r squared equal to. That's the percent it is to being a perfect fit. R squared is 1, so it's a perfect fit. What's the polynomial? Y is equal to? So x cubed minus, so minus 2x squared plus 6x plus 9. Did everybody get that? Okay. Do you see how to do this? Now, once again, we know this was a perfect fit because r squared was 1. So if you went through and did a linear regression line, it's going to be, r squared is not going to be 1. Does that make sense? It's not going to be very close. If r squared being 1 makes it a perfect fit. 100% perfect. Wait. Ready, set, go. Do 1 through 8. This next part is actually kind of interesting. So it says, given these are actually true statistics, you guys, like actual statistics they pulled from these companies. So it says, let x be the number of years after 1985. That's going to be important to us. And then it gives us the world gold production. This year they made this much gold. This year they made this much gold. This year this much, and this year this much. So interesting fact for you. This company would literally come in, because they don't know math, most of them, they're CEOs. They'd come in and they'd hire a statistician to come into their company and just do a project for them. They'd give them this information and say, can you tell me, given that we produce this much gold in these years, what can you expect us to predict? Like, can you predict what we will probably be producing, how much gold in the future, year 2020? So what you would do as a statistician is just use your calculator, and you're going to be making the big bucks just to do it. So literally, this is what we would do. So this is the important part. It says, let x be the number of years after 1985. So how many years is 1985 after 1985? 0, correct? And then this is 5 years after 1985, right? 10? Does everybody understand why? And then 15 years after 1985. So now we're going to literally go into list 1, type in 0, 5, 10, 15. In list 2, you'll type in the world gold production, so you'll type those in. And now what I want you to do is calculate. We're not going to use the n plus 1 point principle, because we could, but I want you to go through and test. Let's try a linear. Let's try a quadratic. Let's try a cubic. And whichever one has an r squared of 1 is the perfect fit, right, everybody? So that's what you would do. So you tell me, is it cubic, linear, quadratic? Test them all. Whichever one's r squared is closest to 1. So does everybody know what they're doing? Okay, tell me which one you got. Now understand, in real world problems, the answers aren't, the actual answers aren't going to be beautiful. They're probably going to be decimals. Because in the real world, math isn't just beautiful 3s and 2s. It's cubic because r squared was 1. So you knew it was cubic, so you should have got this. 0.038 x cubed, right? Minus, you have to put down the full decimal, 0.956x squared, and then plus 8.01x, and then that's a 0, and then plus 49.3. Does everybody understand? So now think about it, guys. If this is the function that matches these points, now can't I go through and plug in input, output, correct, everybody? So I could plug something in and get something out, right, everybody? Isn't that how polynomial function works? Yeah. So think about it. Now we're going to answer, go to problem 15. I'm going to skip to problem 15. Everybody go to problem 15. It says, estimate the world gold production for 2010. So that's what this company would be asking you. How much do you see us making, and how much gold do you see us making in year 2010? So now we've got to put in, 2010. What do we have to put in for x? Well, how many years? We have to do the correct x's. X is number of years after 1985. 25. Does everybody understand why? Okay, so x is 25. So let's plug that in. 0.038. Then 25 cubed. Everybody should be typing this in. So minus 0.956 times 25 squared plus, you guys be really careful, type it in right, because that's what's taking us so long, is we're not being careful when typing in things. 801 times 25 plus 49.3. So if you calculated this right, you should have got around 245.8. Did you get that? You all were getting that about? Yeah. So 245 million, so 245.8 millions of troy ounces. That's just the measurements. That's how much gold production you can expect in 2010. So 2020, we would plug in however many years after that is of 1985, right? 30. And you could take your calculator if you needed to and do 2020 minus 1985, right? Everybody, you all understand that? If you didn't know? Okay, so we're not going to do that, because if you understand that, then we're good. Now I want you to understand, oh yeah, this is one thing I do want you to understand. So now that we know the polynomial, couldn't we go backwards in time? What if I said to you, how much gold production do you see? Because I've literally heard of this happening. A company comes in, they have all these statistics, and they're like, I wonder what we made in year 1975, because our people didn't take books back then. Like, they didn't write down the numbers that year. So then they hire a statistician would come in, get this figured out here, this, and then they would go back and say, okay, well, based on what we've seen from you, probably back in 1975 you produced this much. Does that make sense? Yeah. So that's going back in time. So how many years after 1985 is 1975? Isn't that negative 10? So we'd plug in negative 10. That would be totally fine. Does everybody see how that would work? Okay, awesome. All right, so
Wait.
what we got when we calculated it. It was on for 15. Okay, so 13 and 14 it says, find a cubic and quartic model for each set of values, then determine which model best represents the values. You'll go through, find a cubic, find a quartic, write them both down, and tell me which one is the best fit. So it's whichever one's R squared is closer to 1. Then I want you to go ahead and do problems. So this is what you're doing today. You're doing problems. The front page, the whole front page. Then you're doing, we just did 15 together. We're not going to finish 15. 16 you're doing, and you're only going to do 1986. If you get the picture, then that's all we need to know. Like, why over practice? So 16 and 17 and 18. You only need to do the first one on that. So on 17, you're going to do 2002. On 18, you're going to do 1970. Now, I do want to say one more thing, because I'll have to come back to this if I don't. Last hour, people were forgetting. If in your calculator you got like, if let's say we calculate a cubic, ax cubed plus bx squared plus cx plus d, and then it gives you a is this. You got to pay attention to this. 1.03, and then you get an e to the negative 3. You can't write e to the negative 3, guys. That's just a scientific number. Remember, that's the same thing as you got to move your decimal back 1, 2, 3 places. So we would write it as 0.00103 x cubed. Does that make sense? You can't put the e part into your answer. We're all good with that? You're going to see that. So make sure you remember that. Okay, so that's all you're doing. When you've done that, check it off with me, hand it in. Once you've done that, check it off with me, hand it in. That's all we're doing. The front page. Yeah, and then you're doing only 16, 17, and 18 on the back, and you're only doing the first year. That's listed.